Right now, meteorologists across Europe and North America are tracking the same pattern repeating itself for the second time this summer. Brutal, record-breaking heat collapsing almost overnight into violent hailstorms nobody saw coming until the radar lit up. In Germany, temperatures broke 3 separate state records on the 30th of July, reaching just over 40 degrees Celsius in Bavaria, Saxony-Anhalt, and Baden-Württemberg. Within 24 hours, a devastating sequence of severe thunderstorms, torrential rain, and massive hail tore through southern and eastern Germany, fracturing infrastructure and paralyzing transit hubs across the region. Weeks earlier, on the 4th of July, storms, breaking the first major heat dome of the American summer, produced hail large enough to potentially rewrite Connecticut's state record books. 2 different continents, 2 different heat waves, the exact same mechanism. This is the story of why heat wave collapses keep triggering hail nobody predicted, what the actual science says is driving it, and what has already been confirmed versus what is still being verified. No hype, no exaggeration, just what actually happened and what the data behind it means. Drop a comment and tell me if hail like this has ever hit where you live, because I read every one of these. If you want grounded weather coverage instead of panic headlines, subscribe. It is free and helps this reach people who need to understand this before the next collapse happens. Let us go for 5,000 likes on this one. Thank you. Now let us get into it. The clearest confirmed example of this pattern happened back on the 4th of July, right as the first major heat dome of the American summer was finally breaking down across the eastern United States. A complex of storms moved through southern New England that day, and behind an initial line of supercell-like storms came a strong line packing damaging winds and unusually large hail. National Weather Service meteorologist Bryce Williams described it as a series of storms that produced quite a bit of wind damage in addition to some large hail with wind speeds generally estimated between 50 and 65 miles per hour. Reports came in of hail up to 3 inches in diameter, roughly the size of a baseball, in the towns of Bristol, Plainville, and New Britain. According to NOAA records, the largest hailstone Connecticut had ever officially recorded before that weekend measured 2 3/4 inches, first set during a 1969 storm. Williams said his team could not find any reports of 3-inch hail anywhere in the state's records, meaning this event had the potential to be one of the biggest hailstorms ever recorded in Connecticut's history, a claim still working through NOAA's official verification process. Gary Lesser, chief meteorologist at Western Connecticut State University, explained why those storms held together instead of weakening the way they usually would heading into evening. There was so much heat and humidity still sitting in the atmosphere from the heat wave itself that the storm simply kept feeding on it, meaning the same extreme heat punishing the region for days directly supplied the energy behind the hail that followed it. This summer's second clear example has been unfolding in Germany over the past several days, and it followed the identical script. Following a record-breaking heat wave, Germany's national temperature record was broken in late June when the Deutscher Wetterdienst, the country's national weather service, confirmed a reading of 41.8 degrees Celsius in the small settlement of Mückendrewitz, surpassing the country's previous all-time record set back in 2019. That same late June event had already shown the country how disruptive extreme heat could be on its own, with the DWD provisionally measuring 41.7 degrees Celsius in Brandenburg, tram infrastructure damaged by the heat in Leipzig, sections of the Autobahn closing after road surfaces deformed under the strain, and officials publicly warning that Germany remained insufficiently prepared for extreme heat events of this scale. That heat did not let up. By the 30th of July, Germany was in the grip of its third distinct heat wave of the month, and the DWD confirmed new July temperature records in 3 separate states: 40.5 degrees Celsius in Bernburg, Saxony-Anhalt, 40.4 degrees in Kitzingen, Bavaria, and 40.2 degrees in Olsbach, Baden-Württemberg. The DWD's own forecast for the following day explained exactly why trouble was coming. A weather front across central Germany was separating hot air in the southeast from cooler air further north, a setup the agency said could lead to increased turbulence and severe thunderstorms. Forecasters specifically flagged Saxony and Thuringia as facing the most severe storms, warning of heavy rain, hailstones, and thunder, with as much as 20 liters of rain per hour possible in the northwest. What followed matched that warning, and then some. A sequence of severe thunderstorms, torrential rain, and hail large enough to be described as massive tore through southern and eastern Germany, fracturing infrastructure and paralyzing transit hubs across the region, arriving immediately on the heels of the record heat that preceded it. It is worth being precise about what is confirmed here versus what is still unfolding. Connecticut's potential 3-inch hail record is still working through NOAA's formal verification process, which requires a hailstone to be measured, weighed, and photographed by the agency's State Climate Extremes Committee, along with independent confirmation from a state climatologist, a process that can take months. Germany's hail event, similarly, has been widely reported as severe and disruptive, but no single hailstone size from this specific event has yet been confirmed as an official state or national record the way Connecticut's is being evaluated. What is confirmed in both cases is the underlying pattern, a genuinely dangerous heat wave collapsing directly into severe hail-producing thunderstorms within a day or two of its peak in a summer that meteorologist Simon Young, addressing the persistence of this pattern across Europe, has described directly, saying that what surprises him most as a meteorologist is how stubborn the entire weather pattern has been this year, snapping back into heat again and again rather than settling into ordinary summer conditions. Now, let us get into why this keeps happening. Specifically, at the moment a heat wave breaks, because it is basic atmospheric physics rather than coincidence, the key measurement is convective available potential energy, or CAPE, essentially, how much fuel is available to power a thunderstorm's updraft, the column of rising air that determines how large a hailstone can grow before it becomes too heavy to stay aloft. A multi-day heat wave lets heat and humidity build and build at the surface with nowhere to go, because the same blocked weather pattern responsible for the heat also prevents fronts from moving through to release it. When a cold front finally does punch through, it often arrives aloft. Before it fully clears the extreme heat and humidity still pooled at the surface, and that mismatch, dangerously hot, moisture-loaded air at ground level, meeting genuinely cold air arriving several miles up, produces the steep temperature drop with altitude and extreme Kp values capable of building baseball-sized hail. Storms, feeding on that instability, develop strong, very deep updrafts, capable of lofting hailstones repeatedly through the layer of the atmosphere where ice accretes, adding another shell with each pass, before the stone finally grows too heavy to stay aloft. In plain terms, the very same energy that made a heat wave dangerous for days is the energy that gets released explosively the moment that heat wave finally ends. Researchers studying hail formation, including work from Pennsylvania State University's Yuzhu Lin and Matthew Kumjian, have found that environments with larger CAPE are consistently associated with storms capable of producing larger hail, and that storm mode matters as well, with the same rotating, long-lived supercell storms described in both the Connecticut and German events, consistently producing the largest hailstones observed anywhere. It is worth being careful about the broader climate connection here too, rather than overstating it. This is not a two-event pattern in isolation either. Earlier this year, storms following extreme heat across the American Midwest produced hailstones as large as 6.5 inches in Illinois, larger than that state's existing record, while a separate storm system produced a 7.1-inch hailstone in Texas that has already been confirmed as that state's new all-time record. Research has found that both 2023 and 2024 set new records for the number of 2-inch or larger hail reports recorded nationally in the United States in a single year, part of a trend meteorologists have been tracking closely. But that same research has been careful not to oversimplify the link to a warming climate, since rising temperatures affect multiple ingredients in the hail formation process at once, some of which favor bigger hail and some of which work against it. The honest scientific position is that this specific pattern, dramatic hail immediately following major heatwave collapses in both Connecticut and Germany this summer, is well documented and mechanistically understood in each individual case, even though the longer-term question of whether hail overall is getting bigger because of a warming climate remains a genuinely open, actively researched question. So what does this actually mean for you, particularly if you live anywhere that has recently come out of, or is currently sitting under, an extended heat wave? It means the moment a heat wave finally shows signs of breaking is not the moment to relax. It is often the moment the atmosphere is most primed to produce its most violent weather of the entire event, since all of the heat and humidity built up over the preceding days has to go somewhere once a front finally moves through. It means paying attention to severe thunderstorm watches and warnings, specifically in the hours right after a heat wave breaks, rather than assuming the danger has passed once temperatures start dropping. It also means treating transit and travel disruptions during that window as a real physically grounded risk rather than routine bad luck, given that Germany's own transit hubs were paralyzed by exactly this kind of storm within a day of its record heat peaking. And if you do find hail large enough that it might be a record, the advice from meteorologists is straightforward. Photograph it immediately for scale and get it into a freezer as quickly as possible, since an unpreserved hailstone will simply melt before anyone can verify it. The honest, grounded summary is this. Connecticut's 4th of July storms, which broke the first major American heat dome of the summer, produced hail up to 3 inches in diameter that may break a state record standing since 1969, a claim still moving through NOAA's official verification process. Weeks later, the identical mechanism played out in Germany, where record heat on the 30th of July gave way within a day to severe thunderstorms and massive hail that paralyzed transit hubs across the southern and eastern parts of the country. Both events trace back to the same basic physics: extreme heat and humidity trapped at the surface by a blocked weather pattern, met by genuinely cold air finally arriving aloft as that pattern breaks, producing the instability that lets hailstones cycle repeatedly through a storm's updraft before finally falling. We are going to keep tracking this as severe weather season continues, sourced the same way we did today, straight from the National Weather Service, Germany's DWD, and the meteorologists actually studying these storms, not recycled headlines. Subscribe so you do not miss the next one forming, because based on this summer's pattern, the next heat wave to break is very likely to bring exactly this kind of violent weather with it. And leave that comment below. Tell me if hail like this has ever hit near you. Because behind every one of these numbers is a homeowner. In New Britain, Connecticut sweeping baseball-sized ice off a driveway, a commuter in Saxony stranded as storm damage paralyzed the transit system that was supposed to get them home, and a meteorologist on 2 different continents watching the exact same pattern repeat itself, still trying to explain just how stubborn this summer has actually been. 5,000 likes on this one. Let us go. See you in the next one.